Another way we can utilize chain rules is that we can utilize chain rules by doing multiple chain rules at the same time. So if we have a composition of 3 functions, f composed with g composed with h, then we can apply multiple chain rules with our functions. Let me give you an example of that. We have capital F of x is equal to cosine of the natural log of 2x to the 6th plus 9. So we do derivatives using multiple chain rules. Let's go ahead and do that. Now I'm going to think of this in stages. So first off, I want you to be able to see this f of x as really just a cosine of a u. And that means that if we were to take a derivative f prime of x, we're going to get negative sine of u multiplied by u prime. Now here's the issue. U is a fairly complicated function. So in order to figure out u prime, I need the chain rule of that as well. So I'm going to, off to the side, think of u is equal to natural log of, let's introduce a new variable, v. So what's u prime? U prime is equal to 1 over v multiplied times v prime, where v is obviously this inside function, 2x to the 6th plus 9. So let's go ahead and do that. So take this f of x. We took a derivative. We know that the derivative is going to be negative sine of u. What's u? U is this natural log of 2x to the 6th plus 9. And then we're going to multiply times the derivative of that natural log. Derivative of that natural log is 1 over 2x to the 6th plus 9 multiplied times the derivative of the inside function, which is the derivative of 2x to the 6th plus 9. That's 12x to the 5th. So it's a fairly complicated thing, but if you take your time and be willing to introduce new variables, you can take derivatives of these really complicated functions. Here we have a composition of 3 different functions. We have our polynomial inside a natural log, which is inside a cosine. So there you go. There is not going to be a you-do problem for this because these types of functions are not going to come up a whole lot. They could come up, obviously, but they don't come up very often. So we are not going to spend a whole lot of time doing derivatives of this type.